Hi, in this video, I'm going to show you how to invent real-life situations that could be represented by an expression that you're given. So, as a teacher, I really like to ask my students to do this because I think it really shows me a lot about two things. First of all, whether they understand the operations that are happening in the problem or in the expression, and then second of all, whether they understand what kind of real-life situations lead us to do these operations. So I think mathematically it's a really good and interesting thing to be asked to do. And I'll try to show you when I explain here what I'm going to do for each of the expressions we have, the purple one and the blue one. I'm going to do two different examples. And hopefully by doing two different examples, it'll help you concentrate not just on the answer, because you're going to need to invent your own answers to your own expressions, but to the sort of process that we go through to think them up. Okay, so we're going to start with the expression 3p plus 10. Now what I like to do when I'm coming up with real-life situations, I often find it's easier if I start and I decide what the variable is going to represent. All right? So I try to pick something pretty ordinary so that I can come up with a reason to, say, multiply it by 3 and add 10. And if it doesn't work, if I come up with something that turns out to be too specific or has something weird about it that I can't think of any reason to multiply by 3, then I can try something else. But I find it's easier to start if I know what p is representing. So I kind of start with things like the number of people in a group, the number of people in a room, say. It could be, any sort of very ordinary number. So let's use that one to start with. If p represents the number of people and maybe to be really clear, let's just put these people in a room. You could have the number of people in a basketball team, the number of people, in any sort of situation. But I figure in a room is pretty vague in a way that could be helpful for me because I have to come up with reasons to do these operations. All right, so for the first one, 3p plus 10. So 3p, remember again, if there's no operation between a variable and a number, that means it's multiplication. We don't always write the multiplication sign. So it means that I have to take the number of people and multiply it by 3, and then add 10 to that. So first of all, I need to think, why would I want to multiply the number of people by 3? It's either that each person has 3 of something, is related to 3 somethings, or maybe that there's I have different groups of p people, but I think in this case maybe it's easier if each person is 3 something. So I think what could each person have 3 of? And one thing that works pretty nicely for a lot of these is often if you think of money, it can often help you come up with a nice example. So maybe maybe I'm just thinking about the letter P, but if the people paid $3 each to come in to whatever is in this room, maybe it's a museum or something, then we would collect 3 times p. So if it was 20 people, it would be 3 times 20, it would be $60. So that gives us a reason, if each person pays $3 admission, that gives us a reason to multiply the 3 by the p. So let's start with that. And each person paid $3 admission. And as you're doing this, I would probably make notes to myself, because sometimes you have to go back. Maybe at this point, if it was hard to come up with some reason to add 10, I might say, okay, we won't make it $3 admission, we'll make it something else. Now let's think, if we did have $3 admission, why would we add, I'm imagining sort of someone going around with a hat and collecting $3 from each person, and then how would we get an extra $10 in that hat? Well, maybe somebody just made a donation. And that actually would work nicely. If each person paid $3, that gives me 3 times p, 3 times the number of people, and then someone threw an extra $10 bill, and that is a good reason to add 10 to the total. So that'll work. And someone made a $10 donation. Now, some of my students, at least, they stop right there, which sort of is too bad because it shows that they're really thinking about something good, but they haven't explained it fully. Now we need to explain exactly what 3p plus 10 represents. Then 3p plus 10 represents. So what is it? 3 times the number of people, so each person is paying the $3. That gets us the 3 times p plus the 10. So this is the total amount of money that we've collected. And even better, I think, would be the total number of dollars, to be super clear. Yeah, so that one worked out nicely. All right, now to try to help you understand a little bit more about the process of going over these, we're going to do another example, and we're also going to do 3p plus 10 again. So let's say, suppose we hadn't used any people at all. Let's come up with something else that the p can represent. Like maybe, it definitely doesn't need to be something that starts with p, but maybe let's have it be something, because it could just be like the number of pencils in my pencil case. Okay. P represents the number of pencils in my pencil case. So now let's think, why on earth could we multiply the number of pencils we have? Now I guess pick pencils because it's something very, very ordinary and everyday. And I find it's easier if you pick something really everyday. So why would we multiply the number of pencils by 3? And I was thinking of this, one of the ideas I had, which would definitely work, but I decided not to go with, is I imagined breaking my pencil into 3 smaller pencils. So each pencil would become 3 new pencils because it's broken into 3 smaller ones. And then somehow we could figure out how we get 10 more. And that kind of thing could be work. I thought maybe it would be just a little bit hard to explain really, really clearly. So I left that and started thinking about other thoughts. But any reason why you would multiply 3 by p can work. You just need to explain it really clearly. And I thought maybe an easier one to explain, which is a little bit silly, but very clear, so it's totally fine, was I was thinking, well, what do you do with pencils? Obviously, you write things. So I thought, well, what if with each pencil, the first pencil I did 3 something. I was like, okay, it could be 3 pages of homework. And then with the next pencil, 3 pages of homework, and the next pencil, 3 pages of homework. So 3 pages of homework with each pencil. So then that would be, the total pages would be 3 times p, so that would work fine. And then I need to come up with a reason to add 10, but I think that should be easier. So let's write this down here. So p represents the number of pencils in my pencil case, and I do 3 pages of homework with each pencil. Right? So it's silly. These real life situations can certainly be silly. I don't think anybody would do this, but it's clear and it makes sense. Okay, so now we need to come up with a reason. We've got our 3 times p, that's how many pages are done. We need 10 more, but we don't have any pencils left. Oh, we could just do 10 more in pen. That'll work. And I do 10 more pages in pen. Okay, then just make sure you're really explicit. Sometimes people forget to write the last part. Then 3p plus 10 represents the total number of pages of homework I did. Okay, so let's look at a different expression now. And for the same expression, I'll use these two meanings for my p. So I'll do, again, I'll do this expression with two different examples. Okay, so this one I would say is a little bit harder. The expression is 100, and then we subtract 2p. So there are two things we need to think about this again. Like here, we had to figure out why would we multiply by 3 and add 10. And I think these ones are a tiny bit harder if we're starting with 100, and then we're subtracting 2 times p. So we're doubling p, but then we're going to subtract that number from 100. So I think it's helpful for me at least to think about another way we're thinking of this is we start with 100 and we subtract 2 for everything that's in the p, for everyone. So for example, if it's p represents the number of people, we're going to take away 2 for every person. All right. So if p were 1, we'd subtract 2 altogether. If p were 10, if there were 10 people, then 2 times 10 is 20. We'd do 100, subtract 20. So every person, because it's people here, and every pencil in this example, we're going to take away 2. So let's think. We're starting with 100 of something, and for every person in the room, we're getting rid of 2 of them. So I'm kind of imagining people coming in the room and then something disappearing as they come in. Oh, and one thing, here's something that would work nicely. If we started with a bunch of snacks, and then everybody ate 2 as they came in, that would work beautifully. So we've got p representing the number of people in a room, and there were 100 snacks, to start. And so everybody, what's happening, and it doesn't need to be as they walk into the room, but I think maybe it's just clear, so that to be clear that everybody who's already in the room has already eaten their snack. So each person ate 2 as they came in. Then, so we have to remember to say clearly, 100 subtract 2p represents, so if there were 1 person in the room only, there'd just be 2 snacks gone, so 100 subtract 2, so it would be 98 left. If there were, I said earlier, if there were 10 people in the room, we'd be 100 subtract 20, so there'd be 80 left. So the thing that's left, so it's, well, that's how many snacks are left. Number of snacks remaining. There. So with these ones with subtraction, you want to think, well, what are you starting with? And you might be starting with the part of the expression that has the variable in it. But in this one, we were just starting with 100. And then we need to figure out why we're going to subtract every time that the variable goes up. So let's look at the same expression for the other value of p, and then hopefully it'll help you kind of understand the structure of this. So I've got p representing the number of pencils in my pencil case. So again, we're going to think about starting with 100, and then for every pencil I'm subtracting 2. And actually the same hint that helped me come up with this one, I think can help me here. If I think about money, here it was every person paying $3 admission. If I make every pencil cost $2, be like I started with $100, and then every pencil I got cost me $2. So I'm subtracting because I'm paying the money, so I don't have the money anymore. That will make sense. That'll work. All right, let's write this down. And I had $100 to start. And let's say I paid, I was going to write each pencil cost, but I think it's more clear. Say I paid $2 for each pencil. Then this would be how much we have left. So I think it's a good idea just to double check your expressions. What you can do is go through and choose a value for the variable and make sure that it works. So for example, if we had 6 pencils and they each cost $2, then that means we've paid $12 in pencils. And 100 subtract 12 is 88. So we can check, does this work? It should come out to 88. 100 take away, 2 times 6, so 100 take away, that is in fact 88. So the expressions, this should make sense if you imagine a specific number here. It should make sense and it should come out just with the same value as you would if you substituted the number into the expression. All right, good luck with it.